Good afternoon, dear students. How are you? I'm fine. Okay, today's class we are going to see a new unit, Unit 7, Thermodynamics. So this is one of the important unit from your 11th chemistry. So thermodynamics. What is mean by thermodynamics? So generally thermodynamics means we'll study about the heat process of our daily life. So how temperature is playing a role in daily life. So the temperature variation we will study from this unit. So thermodynamics means from Greek they are derived this is flow of heat. Thermodynamics means flow of heat in Greek. In Greek, which means flow of heat. So flow of heat means what? Flowing heat from one place to the another place, that is flow of heat. So in thermodynamics, so that the term thermodynamics is mean that in Greek it is flow of heat. In Greek, thermos means that is heat. Okay, in Greek. In dynamics means its flow. So dynamics means flow, thermos means heat. So both are together, we can consider this meaning of flow of heat. So daily life we will experience that the flow of heat or the temperature variation in daily life. How? If you heat the water, then applying the heat. So flow of heat from the source to one system, that means water. Okay, then if you stop the heat, then leaving that solution boiled water sometime, then it will lose heat. How? Without any energy, without applying any energy to it, it lost its temperature. Okay, high temperature to lower temperature. How? Its flow of it is flowing or it is transferring heat from one system to the another system. So the boiling water, if you take boiled water, this is water. Now we are applying heat. Applying heat from the flame. So now it get boiled. Okay, because of applying heat or flow of heat from the flame to system, flame to water. Now this water is become the boiled water. Now remove that source of heat, then remain this for in a room temperature for 10 minutes. Now you can observe before 10 minutes it contain the temperature is high temperature. But when you leave that for the room temperature, in room temperature for 10 minutes, so within that 10 minutes, that boiled water, it's release heat energy to the surrounding, to the environment. Okay, so this is flow of heat. That means transferring heat from one system to the another system. Okay, so transferring heat from one first higher temperature to lower temperature, or from the lower temperature to the higher temperature. So this is flow of heat or transferring heat energy from system to surrounding, or from surrounding to system. So thermodynamics is playing the important role in daily life, like this all the process. Then also heat energy, to produce the heat energy, or for cooking also we are using this heat energy. And one of the important role of thermodynamics is flow of electron through the circuit to producing the electrical energy. So one of the important application of thermodynamics, flow of electron. So when electron flows through a circuit, it will produce electrical energy. So how electrical energy is producing? Because of flow of electrons. So flow of electrons is producing the electrical energy. So this is also a heat energy, one type of heat energy. So this is under the thermodynamics application. Flow of electrons through circuit for producing electrical energy. So this is one of the important application of thermodynamics. And also produce heat energy. And next one, using this in metabolic reaction. So metabolic reaction means where it is happen, where happen in this metabolic reactions are happen only in the living things. So during this metabolic reaction, they produce some energy. So that energy is it's heat energy. So this heat energy or the energy is produced by the metabolic reaction. It's using for the biological function. So metabolic reaction which is happen in the living things, the energy is produced. By this metabolic reaction. So the produced energy are used to functioning the biological functions. So this is also one of the important application of this thermodynamic in daily life. So overall, thermodynamics means it's flow of heat or transformation of energy from one place to the another place, or you can say this is transformation of heat or transformation of energy or flow of heat. Okay, so this is thermodynamics and with the applications. How the thermodynamics was developed from the initial stage and how they developed the law of thermodynamics and the mathematical relationship of thermodynamics. During the 19th century, in 19th century, people are used steam engine. So you know that what is the use of steam engine. Before the discovery of the normal train, so before that they use only steam engine to produce the energy to functioning some machines or to functioning the train. Okay, so we used steam engine to producing the energy. So steam engine means the heat energy which is produced by steam engine is converting into the mechanical work. That means what? We use the heat energy which is produced from this steam engine and we use this for functioning some machine. Okay, functioning some machine or moving a train from one place to the another place. So in the ancient time, in the 19th century, during that time, over that time, we use only the steam engine to functioning the train. But nowadays it's developed into the metro and hyperloop. Okay, so this is new technology. So before that, during the 19th century, we used only steam engine. For functioning this steam energy, they experience some problems to understanding the functioning of steam engine, for using that steam engine for daily life. So and application. So how to apply this steam engine from heat energy to the mechanical work. Okay, so how to convert this heat to mechanical work. And how to develop or how to improve the efficiency of the steam engine. So over that time, scientists are discover some law of thermodynamics. So we have some law in the thermodynamics unit. In this unit, first law, second law, third law, and zeroth law. Likewise, you have some law. Okay, so over the time they discovered or they calculated this law and the mathematical relationship of that thermodynamic law also discovered by the scientist. So they that laws are using still we are using that law still to understanding this heat energy to transferring into mechanical work or increasing the efficiency of this heat energy. Thermodynamics are evolved like the macroscopic properties like So it is evolved as macroscopic properties. So what are the macroscopic property? Heat and work. So the principles which are explained in this thermodynamics unit are based on the thermodynamics laws. So 3 thermodynamics law. So first 2 laws of thermodynamics are explaining the actual conversion of energy from different form of energy. Okay, then third law is explaining that to calculating entropy and the relation with the absolute zero Kelvin. Okay, so you already learned that absolute zero. What is absolute zero in Kelvin scale? How we are mentioned that in the previous unit you learned that. Okay, so this third law of thermodynamics will explain that entropy and unattainability of absolute zero Kelvin. Thermodynamics is not a chemical function, it is a physical function. It will explain the flow of heat, and it is independent from the atomic structure and the molecular structure. Then also it is independent with the mechanism or any reaction of the compound which is undergo the thermodynamics process. Okay, and we can easily predict that when the reaction is undergo the thermodynamics reaction is the feasible or not feasible one by this thermodynamics by certain conditions. But we can't derive the rate of the reaction with this thermodynamics, because the rate of the reaction will undergo the reaction and the reaction which takes place in particular time, that is rate of the reaction. So we can't predict the rate of reaction by this thermodynamics reactions. To understanding this thermodynamics unit or understanding the mathematical derivation and all, you should understand, before that you should understand system and surrounding. System and surrounding. So when you understand this basic concepts in this thermodynamics, then you can easily understand this thermodynamics, all the concept, the difficult advanced concepts. So system and surrounding. Okay, so coming to the first one, system. What is system and surrounding? Generally, this universe are separated into two types. First type, system and surrounding, by the thermodynamics unit, or when you consider that thermodynamics, you will separate that universe into two types, system and surroundings. The system means system is a part of universe and they are under the thermodynamic conditions. And system is separated out from the surroundings with the boundaries, or with the boundaries like real boundaries or the imaginary boundaries. When anyhow they are separated, the system is separated from the surroundings by a real or imaginary boundaries is system, and the rest of other things in the universe are known as surroundings. So what is system? It's part of universe. This is part of universe under thermodynamics condition. Under the thermodynamics conditions, and the system is separated by boundaries. It's maybe a real boundary or imaginary boundary. Real boundaries or imaginary boundaries. So except system from the universe, all other things are known as surroundings. So we can see this with an example. Take a beaker with water, and it is in the universe. Okay, now which one is system, which one is surrounding? You know that system is a part of universe, and it is under the thermodynamics condition. It contains some water and maybe it is heat. Okay, it is heated. Okay, then it is under the thermodynamics conditions. Okay, then also the rest of the system in the universe, that all the rest part is known as surroundings. Okay, surrounding. And the system, it is a part of universe, it is under the thermodynamic condition, and also the system is separated from this surrounding, which is separated with the boundaries. So okay, so now you can see this one, this beaker, the system contains some water. This water is undergo the thermodynamic conditions. Okay, now the system contains some boundaries. Okay, the beaker contains the boundaries. This boundary may be the real boundary or the imaginary boundary. Anyway, it is a boundary. Okay, so this system under the thermodynamics condition with the boundary from so that is known as, so in this beaker with the water, this is known as system. Why it is system? Because it is under the thermodynamics condition, and also it is a part of universe, and then it is separated from the universe or from the surrounding with a boundary. It may be a real boundary or the imaginary boundary. Okay, do you understand this example, system and surrounding? And another example for system and surrounding, you can take the universe like this. So you consider this is a universe, and now take a beaker, take a balloon with some air, filled with air. Now it is under the thermodynamic condition. That means we are heating this or applying this, applying some temperature. That means to put this air filled balloon in a cold water or in the hot water, then the temperature condition will be vary. Okay, so the temperature under the thermodynamic condition, it is the variation in the temperature you can take it is a thermodynamic condition. So take this is under the thermodynamics condition. So which one is system? This air filled balloon is the system. So how we consider this as a system? It is part of universe and also it is under the thermodynamic condition with the real or imaginary boundary. We have the real boundary in this balloon, so we consider this balloon, air filled balloon, is the system, and other all the part of universe is known as its surrounding. Okay, so this is another example. And we have some other examples for understanding the system and surrounding. System may be a water in a beaker or any vessels. So that is a system. Okay, and it is separated from the surrounding. So all the remaining part in the universe are known as it is surrounding, and only the beaker containing water is system. Then balloon is filled with air. Then aqueous solution of glucose or any other solution we took in the vessel. So that all under the thermodynamic condition. That means the temperature. If maybe the higher temperature or the lower temperature, but anyway it contains some temperature. If maybe the cold temperature or the very hot temperature. Okay, so it's not at all a matter, but it have some temperature. So that is system. So you can take a system like our body. So in our body we have some metabolic reaction. That metabolic reaction is produce some energy. So because of that produced energy, we can talk, walk, and what are the action we do in daily life or do by our body. That energy are produced from the metabolic reaction. So that metabolic reaction or the energy which is produced by this metabolic reaction, so in our body. So the body, our body also, it is a system from the universe. So the surroundings or the environment which is present in our surrounded by the system is surrounding with the environment. That means we took our body as a system. Now the body which is surrounded by environment, that environment is known as surroundings, and our body we consider that it is a system. Okay, in the basis of system, physical and chemical properties, in the basis of physical and chemical properties, we divided that system into two types. Generally into two types. So what are the system type? Homogeneous, first one, homogeneous, and second one is heterogeneous. Homogeneous system and heterogeneous system. What is homogeneous system and what is heterogeneous system? Like a solution, when you take a beaker of water, all the constituent which is present in that, it is water molecule. Okay, so all the constituent. So that is homogeneous system. Okay, so when you take that, a mixture of water, a mixture of air in a balloon, we fill that balloon with the hydrogen, air, helium, and also with the oxygen or some part of carbon dioxide. Now that balloon, the mixture of air filled balloon is under the type of heterogeneous mixture, because the constituent which is present in that system, it is not same. Okay, so that system is known as it is a heterogeneous system. So how we separate out that system into two types in physical and the chemical properties. Depend upon the physical and chemical properties, we divided that system into two types. First type is homogeneous system, second type is heterogeneous system. Homogeneous system is basically all the molecules which is present or the constituent which is present in the system are same, that is homogeneous system. Example, gas particles in the gas, all the gas molecules in the balloon, the air filled balloon. And when you look at the heterogeneous system, in that heterogeneous system, water particles or water is mixed with the oil. Now they have some boundaries between that two solution, and the constituent which is present in that water and oil, it is not same physically, and the constituent also it is not same. So we categorize that solution under the heterogeneous solution. Then what is surrounding? Surrounding means everything in the universe that not in the part of system, that is called surrounding. So except system in the universe are known as surrounding. Then what is boundary? Boundary, which is separated out the system from the surrounding, which is separating system from the surrounding, is called boundaries. Mark the question. Page 187. Write here what is system. What is system? And mark that the system is a part of universe up to here with the example. It is in the next page. Any two example. Then write the types of system. Types of system, and mark that we are separated out, or we are dividing this system into two types up to this oil and water. Okay, mark types of system. Then next question, what is surrounding? Mark from here to here. And what is boundary? From here to here. Okay students, thank you. Study these questions and understand this question, okay, on the concept. Then you can easily understand this unit, thermodynamics. It is one of the important unit from your chemistry lesson. Okay, thank you students. Study well.